Hi, I am Haraken from Tokyo. Welcome back to BlinkOn and welcome back to the outstandingly exciting lightning talk session. Perfect. So let's use the text chat of Google Meet. The lightning talks will be presented with a recorded video, but the speakers are also joining the session. Let's send the speakers a short message, applause, and emoji using the text chat. And today, we have special guest speakers at the end of the lightning talks, so please don't miss it. All right, so let's get started. Enjoy the lightning talks.
Hi, I'm Dominik, and today I'd like to tell you about color vector variable fonts. These new color vector variable fonts vastly improve emoji rendering quality, and at the same time, they bring down the font size. It's a font file format that the Google Fonts team and I are currently building. Currently, there is already a set of color font formats, but we believe we need a new one that solves the problems with the previous ones. SPIX and CBDT both embed bitmaps, which makes them versatile, but large and suboptimal at scaling. OpenType SVG fonts embed SVG, but they do not integrate well with font variations and require a complex renderer in the font stack. The color v0 format is using the right set of primitives, supports variations and hinting, but is limited in expression. We're building on top of color v0, so let's see how that works. Color v0 allows you to define shapes and assign only solid colors to them. But if you want to make the Twitter emoji smiley with a gradient, you're out of luck, and the solid color is not sufficient. You might guess where this is going. With color v1, we propose to extend color v0 and add gradients and additional graphical tools. We're adding linear gradients and radial gradients, and we add transforms and control points to the gradients so you can rotate, shear, and scale them. In color v1, now you can assign gradients to the shapes. And in order to make the Twitter emoji smiley, we assign a sun-like gradient to the sphere and then compose the layers. The design of our font format follows these concepts. We're bringing the power and expressivity of 2D graphics libraries to fonts. We're adding the typical operations, clip and fill, transform, and compose. Emoji are very repetitive, so the transform and compose tools allow for better layer reuse, which is good for compression. Let's look at the results of our experimentation in making such a color v1 font. Notocolor emoji is the emoji font that's used across Google. Turning Notocolor emoji into a color v1 font, we find that the font size is reduced to a fifth of the bitmap font. At the same time, the color v1 font renders sharply at any font size compared to the suboptimal bitmap interpolation result. If you want to learn more, here you can find the current spec draft. Here you can find the toolchain for building a color v1 font consisting of Pico SVG, font tools, and nano emoji. And you can find links to the work-in-progress rasterization implementation in FreeType and Skia. And last but not least, a set of color v1 demo fonts. Thank you.
All right, hi, this is Daniel Murphy. I'm doing a quick presentation on using glitch.com to create quick web apps. Glitch.com is a really simple hosting website, kind of like GitHub Pages, but it also has an easy online editor, kind of like JS Fiddle, easy custom server-side logic as well, and then you can use it with VS Code and have some version control and forking if you want, in collaboration. Some really quick examples of using Glitch for testing web apps when we're doing stuff. Here's a really simple web app that, or a page that has two web apps, one inside of the other. Here is that page in the source. It's like index and some manifest, all pretty simple stuff, very basic service worker, and then basic server that's just kind of comes pre-rolled. Next example is another simple web app that's for testing manifest updates, and so changing things here will change the manifest for this page. This one has less files. The index is basically just the options. The JavaScript is sort of taking those options and sending them to the service worker, which will take those and serve them for the web manifest. So no server-side logic needed there. The last example here is all about server-side logic. Here is where it's testing sort of client hints, which involve changing headers. And so to make that easy, they're just change the server side to set some headers on the response. So it was pretty cool to see that. So anyways, how do I make things installable? I talked about web apps. Basically, DevTools is your friend. If you look under application manifest, it tells you the errors in your manifest. The main thing you need to do is specify a manifest link in your HTML. You got to make sure it serves, has like name, display, and icons. Then you have a service worker that responds to an offline fetch event. Purpose of glitch.com pages, I would say great for exploration and prototyping. Not good for anything like official testing, because dependencies, etc. Good practices, good to keep a page visible log there. That's helpful for people who are trying to figure out how it works. And then keep the glitch button on the site to make editing and remixing easier. And that's it. Thank you.
Hello, I'm Mike Wasserman. I'm a member of Chrome's web platform team working to extend web application capabilities. I'd like to give you a lightning quick overview and update of our multi-screen window placement proposal. Although the web emerged in an age of single-screen computing, multi-screen devices have become commonplace and even indispensable in certain scenarios. Web developers would like multi-screen platform enhancements, which could be leveraged for dashboards, presentations, games, creative tools, digital signage, and many more use cases. Our proposal takes some initial steps to modernize the web platform for multi-screen environments. First, it extends existing information about the current screen with a Boolean indicating the presence of other screens. Sites can then request information about those other screens and additional per-screen attributes. That context allows sites to specify cross-screen coordinates when moving or opening windows, or to request a particular screen through the full-screen API. This work is complementary to the presentation and remote playback APIs, which mainly target remote screens, as well as newer proposals for optimizing layout on foldable devices. With this proposal, web applications can introspect the virtual arrangement and new attributes of each screen, like whether it's a built-in laptop display or an external monitor, whether the panel supports touch input, and more. Formalizing cross-screen coordinates allows applications to then request bounds on the most suitable screen for a given window. And a new option allows full-screen requests to target the most suitable screen for the given content. Altogether, this enables some really compelling functionality. Sites can save and restore workspaces, choose optimal window arrangements automatically, and avoid some manual dragging of windows between screens. I'm excited to see what else is possible. So you might be wondering, what's the project status? Well, I'm happy to say there's an early origin trial available now. We're getting great feedback from partners, web platform veterans, and W3C Second Screen CG members. We're excited to continue forging ahead in this space. I invite you to try a couple simple demos we've put together and read Thomas Steiner's web.dev blog post on the experimental features that are available now. If you have feedback or questions, please join our discussion session. We have some really interesting topics that would benefit from a diverse set of viewpoints. You can also follow up separately on your own time through the channel shown here. Thanks so much for your time.
Hi, I'm Dan Clark from the Microsoft Edge team, and I'm going to talk about import assertions. First, some background. We want to extend the ECMAScript module system to include other module types to improve the web component authoring experience. But this plan ran into a hitch last year at TPAC. To understand why, you need to know a bit about how ES modules use MIME types. When a module is imported, the server responding to the request includes a content type header indicating the MIME type of the response. The web platform checks this type, and if it is a JavaScript type as expected, it will execute the script. If something else is received, there will be an error instead. As we introduce additional module types, The MIME type is used to disambiguate the type of module we're importing, so we know how to interpret it, like which parser to run. Note that the file extension here is meaningless to the web platform. Extensions are not a reliable indicator of content type on the web, so that's why the MIME type is needed. At TPAC 2019, it was argued that this could lead to a sort of privilege escalation. Now, if you know how ES modules work, you know that you should only import content from sources you trust, because it can result in running script in your domain. But say I don't have this background knowledge, and I'm importing a CSS module, maybe I'd be willing to import it from a site I don't completely trust, or that has lackluster security practices. It's just CSS. What's the worst that can happen? Well, let's say that the site is compromised or turns into a bad actor. Well, the worst that can happen is that the compromised site starts responding to the import request with a JS file containing a malicious payload, perhaps stealing cookies or something, along with a JavaScript MIME type. The MIME type check of the importer will see the JS type and execute the evil code. We're solving this by driving a change to the JavaScript language such that imports of non-JS module types are required to specify the expected type at the import site. The syntax was designed to be extensible, and other future uses are already being discussed. So this blocks the scenario where I only expected to receive CSS, but instead end up executing script. The MIME type check against the asserted type fails, and our hacker is foiled. We've driven import assertions to stage 3 in TC39. TC39 is the group that develops the ECMAScript spec, and stage 3 means that it's a candidate for the specification, and this is the stage where browsers are expected to start shipping the feature. A big thank you to the co-champions of this proposal, Dan, Sven, and Miles. I'm working on the implementation now, and with that complete, new module types will be unblocked. Which is exciting stuff. That's all I have for today. Thanks everyone for watching.
Hello, this is Luke Zielinski from the Ecosystem Infra team in Waterloo, and I'll be talking about our plans to improve how web platform tests are used in Chromium CI. If you've ever used web platform tests, you may know that there are some differences in how the tests are run inside Chromium and how they are run upstream in wptrunner. First is that wptrunner uses the full Chrome browser, while internal tests use Content Shell. And second is that wptrunner uses WebDriver for browser automation, while internal tests use internal APIs. This can sometimes lead to inconsistent results and confusion, like when a seal passes in Chromium, but then fails in upstream wptrunner. This is the most common scenario, but many other mismatches exist, including all other status mismatches, including flakiness that could occur on either side, WPT features like fuzzy matching missing in Chromium, and features implemented in the Chrome layer not being testable in Content Shell. To help this situation, we want to make Chromium WPT behave more like upstream WPT and get rid of some of these differences. By using wptrunner directly, we expect less infrastructure duplication, since parts of wptrunner are currently being copied into the Chromium CI to support WPT tests. Using WebDriver will lead to less engineering effort, since there's only one technology for controlling the browser. Testing against Chrome will lead to more test coverage, since some tests require full Chrome in order to run. And overall, we expect more consistent results between Chromium and upstream runs, which leads to less confusion. Our progress to date has been around addressing compatibility issues, ensuring stability of wptrunner in the infrastructure, and closing the feature gap between the two runners. We also recently began an alpha trial of wptrunner with the payments and identity teams. We set up dedicated CQ bots that allow running CLs through wptrunner directly from Garrett. And we are proud to say that the identity bot has already caught some mistakes in a CL. Our plans in the coming months involve building out more features and transitioning some WPT tests to use wptrunner full-time on CQ. The specific test directories are still being chosen, but we will be reaching out to candidate teams in the near future, and we're aiming for full migration in the first half of 2021. We are taking a lot of care to make this transition as invisible as possible to everyone, but some things will likely end up looking a little different down the road. This could be the way test results look, or the format of test baselines, or the command line you use to run tests on your local machine. Look for PSA emails on BlinkDev as these changes become more widespread. In the meantime, we would love to hear your feedback and questions on these changes, And also, if you'd like to start using wptrunner sooner, please email us at ecosysteminfrainternal@google.com. Thank you.
Hey everyone, my name is Nick, and I'm on the web payments team. Today I'm going to talk about the Secure Payment Confirmation API. The goal of this new API is to enable strong customer authentication during checkout that works at scale for all payment methods and across all merchants. And in doing this, we want to have a great consumer experience, meaning the user shouldn't need to sign up or enroll for every merchant that uses this API. We want ease of adoption for merchants and issuers, strong technology that satisfies payment industry security standards, and privacy preserving by default. We achieved this by creating an API to associate FIDO credentials directly to payment instruments. This means that the user only needs to enroll a credential once to be able to use it with any merchant, and the card issuer doesn't need to have individual agreements with merchants. Also, unlike vanilla WebAuthn, a third party, i.e. merchant, can initiate the authentication on behalf of the issuer. Here's a clip of what the user experience looks like with our current implementation in Chrome using Touch ID on macOS. Here's an example of using the API for enrollment, which looks a lot like enrolling a public key FIDO credential using the Credential Management API. We created a special secure payment credential that is a type of public key credential that is associated to a payment instrument. Then a merchant can use the Payment Request API with the new Secure Payment Confirmation payment method to query for the credential and authenticate the user. This is a sample response that the merchant gets back from the Payment Request API with the challenge that's signed by the stored FIDO credential, which can then be independently verified. The feature is currently in origin trial as of Chrome 86. Over the next couple months, we'll be able to analyze the results of the experiment. And then in 2021, with the help of developer feedback, we'll focus on standardization, productionizing with existing secure checkout technologies such as 3DS, as well as expanding to more platforms and payment methods. Thank you.
Hi, I'm Tal Pressman, and I work on the Blink Arch team in Tokyo on scheduling. But today I want to talk to you about something not related to Blink or scheduling or Chrome. I want to talk to you about what StarCraft taught me about software development. So StarCraft is a real-time strategy game developed by Blizzard Entertainment. And in StarCraft, you play one of 3 alien races, and your objective is to destroy your opponent's base. You do that by building an army, upgrading it, and then attacking. So in our story today, we're going to focus on the Protoss Zealot. The Zealot is the Protoss's most basic unit, and it does 16 damage every time it attacks. However, fairly early on in the game, we can research the +1 weapons upgrade, and that adds 2 more damage per attack to all of our Zealots. So that's a 12.5% improvement to the damage they do, but is it worth it? So on paper, we should be able to just say, well, okay, is the 12.5% worth more than whatever else we could do with our money? But then if we look at real professional games, we see that sometimes the upgrade is valued much more, sometimes it's valued much less. And we want to know why. What's the difference? So if we're playing against a Zerg opponent, the basic Zerg unit, the Zergling, has 35 health. That means that an unupgraded Zealot can kill a Zergling with 3 hits. However, an upgraded Zealot only needs 2 hits to kill the Zergling, thus making this upgrade actually a 50% improvement and not 12.5%. On the other hand, if we're playing against a Terran opponent, the Terran Marine has 45 health. That means that an unupgraded Zealot needs 3 hits to kill the Marine, but an upgraded Zealot still needs 3 hits to kill the Marine. So basically, all the money that we spent on our upgrade is not that impactful. And now you're asking yourself, okay, so what does this have to do with Chrome or software development or any of that? And I'm glad you asked. The relation is that we have a lot of metrics in Chrome, and it's good that we have them. We want to be able to make data-driven decisions on what is good for the product. However, we always need to remember that metrics are at best only approximations of what the user actually experiences and what actually happens to the user. So we need to remember that when we're looking at metrics, we always need to remember to take them in context. That's it from my talk. Thank you all for your time, and bye-bye.
Hello, I'm Hyojin Song, working in LG Electronics. I'm one of the AC members and one of the CSS spec editors in Röttsches and Chromium developers. Today, I would like to introduce an important topic for webOS platform. LG has maintained webOS platform for several devices for rendering web content within various form factors, such as rounded or rotatable display and gesture-based input method. One of the common requirements from those devices is to reduce the memory consumption. Devices have different memory requirements. Chromium has only focused on the specific major platforms, so it does mostly consider low-end devices with 1 or less gigabyte memory. Then why the low-end devices have quite low physical memory? The reason is simply to reduce price. Also, it has different focusing areas such as a qualified big screen with several techniques other than desktop and mobile devices. In that background, how we could consider the memory requirements from low-end devices. I listed some points here. In the foregrounded renderer, MSC media should be seamlessly played, for which backgrounded renderer or services are required to be suspended with quite simple lifecycle policy. We could also consider to cut off unnecessary services such as Chrome extension, PDF viewer, and some pre-rendering features. I show you 3 types of the basic memory policy, but it seems a little bit trivial one though. I could refer to some relevant resources which are open to public. Please refer to the links if you need. Chromium needs quite high memory usage for the performance-oriented design, and I personally like it. As an idea, we could consider to provide a memory configuration profile for low-end devices. If I can describe 512 megabytes as an input of the configuration profile, some memory-related constants could be automatically adjusted. For more specific device requirements, someone could change parts of them referring to the profile. Also, we have a hesitation on how to upstream our internal changes. If someone has an idea for it, please guide me. Thank you.
Hello everyone, my name is Yannic and today I would like to present our results on accelerating builds on macOS with Goma outside of Google. First of all, I would like to mention that I do work for Angelo, a company that offers a commercial remote execution platform. However, most of the results in this talk should be transferable to other remote execution backends as well, as long as they can run on macOS. As we all have experienced, building Chrome can take a really long time. People that we talk to have reported build times of more than 3 hours, even on fairly large machines, and I do remember builds taking 5+ hours on my MacBook when contributing to Chrome. Jumbo builds, if you remember them, did help to reduce that, but they had a negative impact on incremental build times because of the larger translation units, and were removed from Chrome's build system last year. Looking at the build times of Chrome a little further, it becomes clear that the majority of time is spent on compiling C++ code, which is easily parallelizable. This makes it a perfect fit for remote execution, which allows distributing builds across many cores while avoiding to buy everyone a large and expensive machine. The way to achieve remote execution when building Chrome is to use Goma, which is available for Linux, Mac and Windows to Google employees and for Linux to active external contributors. But as of today, there are no plans to make it available publicly for macOS or Windows. Fortunately, Goma Server, which acts as a proxy between the Goma client running on the developer machines and the remote execution backend, has been open sourced as part of making Goma for Linux available to external contributors. However, setting up and maintaining a toolchain that can be used to use Goma for building Chrome is not straightforward. A second challenge that we had to overcome once we have figured out how to create a working toolchain for Goma Server is that Goma on macOS expects a hermetic Xcode toolchain, which means that Xcode is checked out as part of cloning Chrome. Luckily, most of the code for that is already open source. However, actually downloading Xcode from GCS requires Google credentials, so it's not available to external contributors as well. Another problem that comes with using Goma on macOS is Xcode's licensing model, which requires that the license agreement is accepted on every machine, so we can't just upload the binaries as part of the compiler invocation. Once we were able to overcome the aforementioned challenges, we were able to run Goma builds on macOS and evaluated its performance. For this, we used the clean checkout of Chrome, compiled everything and measured the time for recompiling it with a modification of macros.h, which is included in almost every translation unit. On my local 8-core iMac, compiling Chrome took around 3.5 hours, while the same compilation on our 28-core remote execution cluster took only about 2 hours and 15 minutes. This is a reduction of about 30% and matches the increase in actions that are executed in parallel. So we are confident that we can achieve even better build times with a larger cluster. For fully cached builds like you would get when building after running Ninja clean, build time is mostly constrained on the available bandwidth to download artifacts and took around 30 minutes on my machine. Thank you for your time, and if you have questions, don't hesitate to reach out to me.
Hello, this is Antonio Gomes from Italia, and I'll be presenting what is LaCros. LaCros is an architecture project to decouple the Chrome browser from the Chrome OS window manager and system UI. On Chrome OS, the system UI, including the Ash window manager, login screen, among others, and the web browser are the same binary. LaCros separates this functionality into two binaries, hence two processes, Ash Chrome, System UI, and LaCros Chrome, web browser. Both binaries are built out of the same Chromium Git repository, however, might be built at different versions. That allows browser and Chrome OS to update independently. Some of the key LaCros components are Chrome OS's built-in WLAN compositor, also known as ISO, and the native Linux WLAN support on top of Ozone. The scope of the project includes adding Chrome OS-specific capabilities to Chromium WLAN, so that it acts like the Ash Chrome web browser. Ozone is the abstraction layer for graphics and event handling. It is based on backends, including DRM, WLAN, and X11. ISO implements a display server, in this case the WLAN compositor, on top of Aura Shell. It uses the WLAN protocol to communicate with clients. Arc and Crustein are examples of subcomponents that make use of ISO's capability to run Android and Linux apps, respectively, on Chrome OS. ISO makes use of WLAN protocols to provide functionalities not available in core WLAN. Stable WLAN protocols are preferred. However, there are examples of non-stable and Chrome OS-only protocols also available, including Aura Shell, Remote Shell, and Full Screen Shell. This is an example of a command line that I use to launch LaCros Chrome on desktop Linux for development. And that's the result. By clicking on the Chromium icons at the bottom, I can launch Ash Chrome web browser and LaCros Chrome side by side. Looking at the command line more carefully, we can see that Ash Chrome launches on top of the Ozone X11 backend for Linux desktop development. It also enables ISO and the existing LaCros support, so that we can launch it. By analyzing more closely the LaCros Chrome and Ash Chrome web browser windows, we can see visual differences, including the rounded corners, scroll bar style, thickness and fade behavior, as well as the window frame border and the resizing behavior. Igalia collaborates on these projects to make these visual differences, among other tasks, to go away. To learn more about it, do not hesitate to reach out to toniquito@igalia.com. Thank you.
Hello everyone, this is Mustaq from Blink Interactions team. This talk is about capability delegation. Capability delegation means allowing a frame to dynamically transfer some ability into a subframe. We have 2 points to note here. We are interested about dynamic delegation, which means some time constant delegation, unlike iframe attributes. And secondly, this makes sense only for APIs that are restricted in a subframe, like geolocation, payment request, pop-up, full screen, etc. Why we are doing this? Suppose your bank website has a branch locator service, which is actually done through a mapping site in a subframe. So that site shouldn't know your location except when you click on the branches near me link. So this kind of time constraint access to geolocation API is only possible through a dynamic delegation. We have a second example with payment request API. We have a demo thanks to web payments team. So many shopping sites use a third-party payment processor website to complete the financial transaction. So when you click on the Pay Now button, the shopping site sends a request to the subframe. That subframe can use payment request API to complete the transaction using this flow shown here. This use case is not possible today without a hack, and we want to fix that. So our goal for this project is to define a generic API for capability delegation, most likely based on post messages. And individual API owners will define what it means, what happens to that API after delegation happens. Our second goal is to really make a complete example here. Like in this case, we want to implement delegation of payment request API so that we can enable the payment flow I've shown you before. This still at an early stage. We have quite a few challenges. For example, we don't want to delegate too much. Like delegating full screen shouldn't allow pop-ups or geolocation, etc. We should prevent possible abuses of delegation, like multiple delegation or chaining of delegation. Delegation should never override user preferences. Like if user says, I don't want pop-up on site X, that shouldn't change even after delegation. Some capability has permission dialog associated to it, and the dialog should be attributed to either sender receiver in an appropriate manner. So that's it from me. If you have any questions, concerns, new use cases, please let us know. Thank you.
Hello everyone, I'm Rahul from Microsoft, and I'm going to be talking about Elastic Overscroll for Windows. So let me start off by defining what overscroll is. It's basically the rubber banding effect that you see when you're scrolling and the user runs off the edge. So traditionally there was a class called input scroll elasticity controller that pretty much used to handle all the core overscroll logic, right from state machine initialization all the way up to curve building, and all of that was available only on Mac. So we had to first identify parts of the input scroll elasticity controller that could be moved up into the elastic overscroll controller. And by doing so, we also managed to reduce code duplication between the two implementations. So next, I'd like to point to specific scenarios where the Windows-based curves would be useful. The first one is a manual scroller pullback. This is when the user pans the scroller beyond its bounds. We have a hyperbolic tangent function that pretty much determines how far the scroller is actually allowed to scroll. And at that point, if the user decides to lift the finger off, there's going to be a backward bounce animation that gets played, which is based on a Bezier curve as seen in figure 3. The next scenario is a fling. Fling is basically when you pan and lift the finger off and the scroller keeps going. So in this scenario, what happens is when the scroller reaches the end, there are going to be two animations that get played. The first one is a forward animation and the next one is a backward animation, both of which are Bezier based. And here it's important to note that these Bezier curves have control points which are determined dynamically based on the velocity of the fling. So here's a quick look at how fling overscroll works. The input handler proxy eventually ends up calling elastic overscroll controller, where a bunch of state gets initialized and the fling velocity gets updated. It then eventually calls the set stretch amount on scroll elasticity helper. And also on every frame, the elastic overscroll controller keeps animating the scroll deltas for the scroller based on what platform it's executing on. So in this demo, we can see that when the user pans beyond the bounds, the hyperbolic tangent function tells how far it can actually move. And then when the finger lifts off, you can see that it bounces back. So here you can see pretty much both fling and overscroll in action together. When the user actually flings and reaches the end, both animations get played, the forward and the backward animation. So currently this feature is off by default, but please feel free to try it out in the 88 release. The name of the feature flag is Elastic Overscroll Win. Huge shout out to the code reviewers, Robert Flack and David Boken, for doing the code reviews. And if anyone has any questions, please feel free to email me. My email address is arakeri@microsoft.com. Thank you.
Hey everyone, my name is Joey. I work on the DOM team in San Francisco, and today for my lightning talk, I'm going to talk about making hidden content searchable with two new features I've been working on, the beforematch event and content visibility hidden-matchable. So first, the beforematch event. It's a regular DOM event that fires before the browser scrolls to the active match of text when searching with find page or scroll text fragment. And the second is a new CSS property called content visibility hidden-matchable. And this makes everything beneath it visually the same as content visibility hidden or display none, meaning that it doesn't take up any space in the layout, but it still allows find page and scroll text fragment to search the underlying DOM inside of it and fire beforematch events on it. So when you combine them together, like in this really minimal example, you can have like a div, in this case, like the small hello world div, and put content visibility hidden-matchable on it, and then attach a beforematch event listener, which removes the content visibility hidden-matchable property from it to reveal the text when it gets searched for before the browser scrolls to it. And as you can see in the video here, we have some expandable and collapsible sections, kind of similar to a details element. And when find page is used to search the text inside of it, it expands via the beforematch event listener. And so there's some privacy issues with this. Obviously, we don't want to tell the page everything about what you're searching with find page. So we came up with two privacy mitigations. The first one is that beforematch will only be fired on content visibility hidden-matchable subtrees. So it's not going to fire, whenever you're searching for any normal text on a web page, text that's already visible. And if the page doesn't reveal this match in response to the beforematch event, we're going to prevent that document from seeing the beforematch event anymore. And the current status is that I got implemented in Chromium. It's currently an origin trial in AMP, and I proposed it in the wwg HTML GitHub. Thanks for watching.
Thank you very much, all the speakers, for the amazing videos. And thank you very much, everyone, for sending heartwarming messages to the text chat. And finally, please send a storm of applause to all the 40 Lightning Talk speakers who created high-quality videos. So thank you very much. All right, so today, we have special guest speakers, and I want to call them Goodger and Ben Galbraith.
All right. Hello, everyone. We are the Chrome Bens. He's Ben Goodger, Google's web platform team lead.
And he's Ben Galbraith, the team's product lead. We're here today to get to the bottom of one of the perennial debates of our industry, a topic that joins some of the classics, such as
Emacs versus VI,
tabs versus spaces. Actually, is this still a debate?
Well, it depends on which side you're on. Gecko versus WebKit and Blink.
Canvas versus DOM.
But we don't want to waste your time on anything as trivial as any of these topics. Instead, we're putting our energies behind that perennial, long-running debate topic.
No, not that one. Which pie is best? Savory pies or sweet pies?
Now, personally, I think the answer here is clear, but there's some disagreement between the Google Chrome Ben community. And so we'll be taking turns making our case and helping you form your own opinion that sweet pies are the best pies. And to kick things off, I'll turn the time over to other Ben.
Nicely done. I'll keep this to the point. Savory pies are the lunch of the people. First of all, they're cheap. Next slide. They're readily available at scale through industrialized fast food. Next slide. But they're also available through your local independent piery in a carefully parameterized and customized form. Next slide. They come in many flavors, basically any kind of food that you like, any hearty winter stew or curry or braise is available in a pie, and you can make it portable. You can take it with you. And it's not just meat. Next slide. You can also find vegetable curries, cheese, and tofu, and other kinds of pies. All savory pies are delicious. And on that note, I'm going to hand back over to Ben to pick up the losing side of the argument.
Thanks, Ben. Well, first, I have to say, I've been surprised at the shocking quantity and depth of arguments in favor of sweet pie superiority. In the interest of time, I've had to condense these down to 3 points, and I'll get started now. First, next slide, I will show how objective scientific user research makes this case clear. Next. What I did is I found a representative population cross-section in 10 diverse samples with ages ranging from 5 to 40-something. And I found a 90% stated preference for sweet pies over savory pies, which I submit is clear, conclusive scientific evidence. Next slide. For illustrative purposes, here's one of the samples. Let's call her Abigail. And here you see how this group of people expressed a very clear, unambiguous preference for sweet pies. Next slide. My next point is how scientific insights on diet health support the case for sweet pies. Next slide. Turns out there's a bevy of leading authorities such as the Nest, which show you clear evidence in support of the benefits of dessert. Desserts are clearly really good for us. Next slide. And as we all know, sweet pies are the superior form of dessert. this is a point, next slide, that's not up for debate this morning. It's one on which we both agree. Next slide. However, scientific evidence shows that, I don't know what happened to the text on this slide, but scientific evidence shows that a diverse diet is actually best for, here it is, for nutrition adequacy. Our species really needs diet diversity. Next slide. And here's the problem. As you know, the savory pies can be delicious. Next slide. But a large percentage of the calories of savory pies come from the crust. Next slide. This is a representative recipe that shows that 66% or more of the calories come from this crust. Next slide. And so we see that if you want to participate in the proven health benefits of a sweet pie dessert, and science says that you should, if you also consume a savory pie, it turns out there's a significant non-diverse calorie overlap between the two, meaning, next slide, that you will find yourself locked out of the benefits, the proven scientific benefits of that sweet pie dessert if you indulge in the savory pie. Next slide. So the scientifically recommended diverse dinner and dessert protocol for optimum nutrition means that you really need the sweet pie, not the savory pie. Next slide. Finally, this is the more serious point. Personal safety is significantly enhanced by avoiding the savory pie. Next slide. Respected authority on this matter, Kaido, from Anantech forums, indicates this dilemma by illustrating that there's a very narrow safety band between overhot chicken pot pie and lukewarm mush chicken pot pie. This is further reinforced, next slide, by respected and verified Twitter account Jay Forsett, who indicates the hazards of chicken pot pie consumption. And here we see, with the high engagement of this tweet, way above the median tweet like count of 0, that lots of people agree with this point. Next slide. And then we see widely respected institutions such as the Detroit Free Press backing up this point, showing that it's not just chicken pot pies, my friends. It's really all forms of savory pie that present this health hazard. Next slide. And we in the sweet pie community have overcome this problem. Some of the sweet pies can be served warm, but they come with an integrated personal safety device and food pleasure enhancer that really mitigates the potential harmful effects of overwarm pie. And so thus, I submit that sweet pies are the superior form of pie.
Well then, clearly we have some differences of opinion on this topic, Ben. Both the correct opinion, which is mine, and your opinion as well, which I'm happy that you've shared with us and you've had the time to do that. Even though we have these strong differences of opinion, I think we can both agree that we really love pies. On a more serious note, thank you everyone for coming to BlinkOn, participating, and for all of your contributions to make Chromium, other browsers, and the web as a whole better. It's really amazing.
Thank you, everyone.
Looks like it's up. Okay. So I would say, regardless of which kind of pie you prefer, savory or sweet, or maybe something else, salty, sour, bitter, maybe we could conclude from all this that there should be pie. And in any case, no matter what kind of pie you prefer, I still want to thank you for joining BlinkOn 13. And I hope that you've had as much fun at the event as I have. I also want to give a big thank you to everyone who left kudos. I think that's it's super helpful for us to be able to share some of the highlights from the event. So I want to give a shout out to scheduling performance gains, prioritizing rendering, and manifest and store focused enhancements as being the 2 sessions with the most kudos. If you missed those sessions, you might want to take a moment to go back and watch the videos. I also wanted to read aloud a few of the quotes that people passed on through the kudos forums about what this event meant to them, what they took away from sessions. So about the web platform interviews session, someone shared that there was super interesting insight into the earliest days of the web. About scheduling performance gains, someone shared excellent insight into this project and the gains that the web platform saw from this work. So I think an interesting insight there is sharing a little bit about impact of work that's happened seems to be something that people like in sessions. Tips and tricks for testing with WPT. Got one really simple piece of feedback. Awesome presenter. So great job. And the talk's Instant Web had the feedback, really clear, crisp, and inspiring overview of the big picture space of instant and seamless loading. Before we wrap up today, I want to repeat our solicitation for feedback. I really hope you enjoyed the first virtual BlinkOn conference, but we'd really like to iterate and make sure that this experience keeps getting better. So you'll be seeing a feedback form shared out by email. I want to encourage everyone to take a few moments to fill it out. We can only really make this event better for everyone if we hear from you. So anything you want to share with us about both the good, the bad, the neutral suggestions are very welcome. Please enjoy the rest of the day, the rest of the sessions, and I look forward to seeing you soon.
Thanks so much, PJ. To everyone, good morning, afternoon, or evening for one final time. Thanks to you and your participation throughout the past 2 days. I don't have many announcements to highlight today. The most important things for you to know are regarding the recordings. So all of the day 1 and day 2 recordings have been uploaded to YouTube and added to the schedule. We'll add the day 3 recordings throughout the day today. So please continue to check both YouTube and the schedule to catch up on any sessions that you may have missed. And like PJ said, we will be sharing the feedback form at the end of the event today. So please use it as your opportunity to tell us what worked and what didn't. And like I said, I don't have much to share today. So just like that, the session has come to an end. After a very short break, we'll see you in the next one, which is beginning at 7:35 p.m. CEST, 3:35 a.m. JST, and 10:35 a.m. PST. Thanks again, everyone, and enjoy the final day of BlinkOn 13.